Good morning, everyone. Thanks for joining the webinar about securing your network with Elastic and Corelight. My name is Samir Benasser. I'm one of the solution architects at Elastic. I will be presenting this webinar with Farhan Khan, which is a sales engineer lead at Corelight. Farhan, you want to introduce yourself?
Good morning. So my name is Farhan. I'm the lead sales engineer for Corelight. And today we are going to talk about defending your network using network data along with Elastic.
Thank you. Do small about the Elastic Stack for people who are not familiar with Elastic. Our solution have different components that help you to collect all the data that you need to collect. For example, we do have Beats and Logstash that are agent and ETL tools that can collect all different type of data, logs, application logs, and also your security data like firewalls data, etc. And plus, we have recently acquired a company called Endgame, and we released a product called Elastic Endpoint, which help you to collect endpoint data and index them to Elasticsearch. Today, I'm not going to talk about Elastic Endpoint. We are going to focus more about how we collect network data and how we can get value from it and how we can do detection and threat hunting using this data, network data. If you want to learn more about Elastic Endpoint, there is a webinar today at 5 p.m. GMT or 9 a.m. PST. And I invite you to go to this webinar to learn more about Elastic Endpoint and how important is endpoint data for protecting your network and also for improving your detection. Now, once with this different component like Beats, Logstash, Elastic Endpoint, and also Corelight, you can collect all the different data. You can store them in Elasticsearch, and Elasticsearch is our distributed search engine and analytics platform that will help you to analyze all this data. All this data that we send will come in specific formats called Elastic Common Schema. I mean, Beats and Elastic Endpoint and also Corelight all send the data in Elastic Common Schema. This means you will be able to correlate all the different data. You will be able to start your investigation, for example, from the Corelight data after pivot to the endpoint data because they have the same schema. It will be easy to correlate them. Now, once the data is in Elasticsearch, you can do a lot with it. We provide different type of detections. We provide rule-based detection using our watcher alerting, but we also have machine learning based detection, which is unsupervised machine learning for anomaly detection. And on top of that, we have our visualization, which is Kibana, that have also a SIEM app, which is a curated UR for security, and also is well integrated with our machine learning capability, and also can work with any data that Elastic Endpoint and Beats and also Corelight send. You'll be able to visualize them and navigate through this data in our SIEM app and do investigation in the SIEM app. Plus, Kibana, of course, have more features, like you have the SIEM app, but you can create your own custom dashboard, your own visualizations, and also you can use Canvas to create more visualization with your own infographics. Yeah. Now, and of course, we have also large community that are creating and generating a lot of security content that complement what we have. I recommend to see what the security community also is building now around our stack. The reason most of the security analysts and SOCs are adopting our technology is really for three main reasons. First is the scalability of our platform. Elasticsearch is a distributed system. You can scale. When we say scale, you can scale to allow you to index all type of data and also large amount of data that you need for investigations and detections. But also it scales when you want to search. It will help you to search that data at speed, which means we prepare the data to be searchable at speed, meaning you will be able to search real-time data and historical data very, very fast. Especially when you do threat hunting, it's quite important to have data ready for search without needing to wait or need to do any transformation. And the data will be already prepared for you to search fast, and also to run machine learning on top of it. And plus, we help you to find relevant information. Yeah, especially using our machine learning, we can really find anything abnormal in your data, and also help you to drill down to the event that created this anomaly and reduce the time that you spend to do your investigation. So really, what's important is really to help you to investigate and now, as I said, recently we released Elastic Theme, which is our curated UI that support, you can see that have curated visualizations for host data that you are collecting, but also for network data. And it have very nice timeline UI that help you to investigate. Now, we have also integrations with different platforms to collect host data. We have AuditB that can capture audit logs and also do file integrity monitoring for different operating systems. We have AuditB module for capturing all audit logs from Linux kernel, etc. But we also have for Windows, WinLogBit for capturing Windows events, and Sysmon to capture Sysmon data. And this will work out of the box with our SIEM solution. Now, with endgame integration, also we have with endpoint integration. Now it's not only about collecting security data. We can also prevent from adversary to attack at the source. I mean, we can prevent, for example, from malware to get executed on the source itself. And plus, it can detect and also respond to an attack. You can really speed your remediations. Like if you detect a malware in the host and you want to isolate the host, you will be able to do that. I mean, I recommend to see the webinar this afternoon. You will have more details about Elastic Endpoint capability. Today, we're going to focus on network data. And as you see, we have integration with different systems. We have integration with the Suricata. We can also capture network data. We can have integration with Axite, Ceph. We can also collect data from firewalls like Cisco, Palo Alto. So we have already out-the-box integrations, and also with the latest technology like Kubernetes, if you want to capture core DNS data, etc. Now, today we will talk about Zeek integrations, and I will give I will let my friend Farhan to present the integration of Corelight and share more about Corelight.
Thank you so much, Samir.
Thank you.
Let me share my screen. All right, so as Samir spoke about the rich Elastic Stack and the visibility part from the network, now there has been a lot of discussion around the maturity of this space, and Gartner has taken a stand around to give visibility to the SOC, and they call it the SOC visibility triad, wherein your SIEM and the UEBA sits at the center of all action. You have an EDR, which gets data from the endpoints, and what's really missing is the network detection and the response part. And this is where Corelight and Zeek fit in. From a stack perspective, the Elastic would be at the SIEM level, the endgame at the EDR, and Corelight provides the rich security metadata that is fed into Elastic to do faster incident response, better threat hunting capabilities. Now, when we talk about how do we get this data out, as you all probably know, when you boil things down, no matter what security product or service you use, they're all trying to improve security based on better visibility of data. So if you have better data, which is better evidence, then you can perform better security investigations. And there are really four major sources of this evidence that security guys can use. You can get data from endpoints like laptops and smartphones and PCs. You have hosts and clients and servers sending data, third-party intelligence services and feeds, which provide intelligence based on IPs, hashes, viruses, and so on. And finally, the network traffic itself, which is inside your network, which contains a ton of vital security relevant information, but it's buried in an ocean of irrelevant data, and it's hard to pull out and make sense of it all very quickly. Today, we will talk about monitoring networks, and we will discuss why they are such a rich source of evidence which can be used for threat hunting and incident response. Now, network security isn't really about your network. It's about the data or the evidence that passes through your network. There's a wealth of information flowing across your network as of today, and that is critical to securing your organization. Every email, DNS request response, a website visit, a download of a file, an IP address, malware C2C communication, beaconing activity, etc. They all traverse your network. Your network holds clues about things like software versions, languages being used, DNS queries and files being sent and downloaded, evidence across lateral movement, and more common, we see Bitcoin mining and so on. All this traffic has to traverse the network, and if you can gather this rich evidence and transform it into rich security metadata, then you will be able to have better visibility and better response capabilities. If you can't see this evidence, you basically are flying blind and more vulnerable than you need to be. So what are the key sources of security risk? I think we all agree that gaps in visibility is a big risk. Even with tons of data, most security operation centers face gaps in their visibility. And why is that? One of the reasons is sparse data sources like NetFlow, which provide a lot of high-level visibility, but do not really have security-related context when you actually need it. Logging isn't always active for systems throughout the enterprise. Example is like system admins often turn off logging for performance reasons. Sometimes it's the coverage is not enough because of budgets. And there isn't a practical location to store all this information that is required by security teams. From the operational complexity, day-to-day security operations, they face many operational challenges, too many alerts being one of them. Then with alerts comes false positives. It takes too long to resolve many of them. There's often so much data from so many sources that it's hard to integrate, it's hard to digest. Or the other side, there may not be enough data which has the right amount of attributes which you would need to do an incident response or a threat hunt. So that's what are the key challenges. So in order to reduce risk, what do we need to do? I think we will all agree we need to find threats quickly. If we can find threats quickly, we can either contain them, have better response measures in place, act quickly in an event of a breach, and be judicious about finding or adding security tools. We will be choosing things more carefully based on the evidence that we have. So if this is so important, what are companies doing as of today? What do they normally use when we talk about this sort of rich telemetry that is passing through your network? Customers would be doing PCAP, and PCAP is very common. We've all used it at one point in time. And this provides a lot of information, a lot of wealth of information. The PCAP or a packet capture has everything that you would ever need. However, you cannot keep PCAPs for a long time. The storage overhead, the resource overhead, filtering of security only data becomes a labor-intensive process, and it's not quick either. The other side is the network performance logs, and these logs are often used in this space, and they overlap with what security logs would mean. And they are mostly around, they contain a lot of network data, but were not designed or developed for security use cases. These are basically device health log. It's not just data designed to allow blue to catch red. Logs aren't correlated and they're not linked in a way that makes it easier to pivot from one protocol to the next. And then you have, system and app logs coming from multiple systems, and you try to correlate them in the SIM. Now, talking about Zeek. So Zeek is a new name for the long established Bro system. And Bro was originally developed by Dr. Vern Paxson, who is also the chief scientist of Corelight. It was jointly designed by a team of researchers back in Berkeley Labs back in 1995. Zeek is a powerful network analysis framework that is much different from the typical IDS that you may know. It has a very long history, makes it one of the most comprehensive network security monitors out there. The data is highly structured, real time, and while focusing on network security monitoring, Zeek provides a comprehensive platform for a more general traffic analysis as well, and is grounded in 20 years of research. So how do we fit in the stack? Everybody talks about a stack, and where would you keep the Corelight or the Zeek appliances? So we sit out of band, and if a customer has a packet broker, then we can correlate all information and consolidate it on the packet broker, and the packet broker would then send this raw traffic to a Corelight appliance. We would then convert this raw traffic into rich metadata and send it up the Elastic stack. Our appliances, can churn up to 25 gigs of traffic per second, and it's all converted and parsed across each protocols to make it easier for SOC operations and SOC analysts to do threat hunting. This is the modern security stack, where we collect the information first, collect the right data 24/7, so that when there is an incident, you have the data you need to close that visibility gap and resolve those incidents faster. Monitoring networks at strategic locations is the fastest, most comprehensive, and the least obtrusive step you can take. The second step is the analysis of it. Ensure that we are extracting data that can be relevant and useful in security investigations. Terabytes of PCAP files aren't really useful day to day. It is much more useful to have the most important data that incident responders will need at their fingertips as they follow threads and clues to try and understand the context of an attack. And finally, the combination. You combine data from different systems, include behavioral data that can come from evidence and the foundation for a successful investigation, and help resolve incidents more quickly. NTA, or the network traffic analysis, is complementary to other data sources. And most companies have implemented some sort of flow-based solutions in PCAP, and modern security stack relies on data-driven analysis by humans or machines, but they need to have high visibility on data that is relevant to take those decisions. Visibility is power. Now, when we talk about the Zeek data, or the Bro data as we used to call it, Zeek transforms gigabits of raw traffic into comprehensive network logs, organized by protocol, linked by fast pivoting, and helping incident responders to take that decision 10 times, 20 times faster. All logs have a common timestamp to make time-based correlations quick and easy. TCP connections especially are giving a unique ID to make it easy to pivot across a connection and find all activity that happened during that session. We will be doing a demo for it so that you get visibility as to how these pivots happen. All files are hashed and given a unique file ID, which makes finding files across your environment very, very easy. And there was a question earlier, can you extract files? Corelight can extract files from the wire at wire speed. So whether you have files like Office documents, Java, Flash, archives, we can all extract them and send them to an external storage like an SFTP folder. And from there, you can have your sandboxes pick them up and use them for further analysis. Data from external systems can also be managed within Zeek. Location people to make Zeek easier to manage and interpret. So Corelight Sensors are built on this rich framework created by Dr. Paxson. And what the capability of this framework is that it provides comprehensive visibility across data. Over 500 elements of data, 50 plus protocols from layer 3 to 7. Zeek as a framework is also part of many curriculums around the world, including SANS and Cisco. So they're also focused heavily on making sure that people understand the need of having rich network data to be better at incident response and threat hunting. And customers of Corelight have measured up to 20 times faster incident response compared to when they were not using Zeek. And Zeek appliances or Corelight appliances are used to do both north-south, which is traditional view of security, and east-west, which is around lateral movement. And all this data that we're collecting from both north, south, east, west is then fed to the Elastic Stack and is visualized based on Kibana. As I mentioned earlier, Zeek is deployed out of band. It's easy to set up and can't be detected or evaded as long as we're getting the traffic. And it's easily integrated to the Elastic Stack. We were one of the first ones to be compliant with the Elastic Common Schema as a technology alliance. And because of Zeek logs are so efficient, typically we only need about 1% of storage volume as compared to PCAP. So which means you can keep Zeek data for a really long period of time, which means you can have a better anomaly detection, behavior analysis, because you can retain that data for a longer period of time. So traditionally, Zeek was used in on-premise solutions, but now we know that the networks are getting more and more hybrid. The network, the perimeter is expanded to the cloud, and we provide the same level of visibility across any surface that a customer or you would be using. So whether the data is in the cloud, the data is on premise, or it's a hybrid mix between clouds, we would be able to get that visibility to you. If a customer has multiple locations, multiple data centers, we also have something called a fleet manager, which basically connects to all Corelight appliances and provides a single pane of glass to push this traffic or to have visibility across all your data points or data ingestion points. And then we can do some fork and filtering and send all the relevant data to the Elastic Stack for reporting, visualizations, machine learning, and analytics on this. This is the high level architecture in terms of a normal network that we see on-prem. So you have your firewalls on the perimeter. We tap on the network using a packet broker, and then a copy of that traffic is sent to the Corelight sensor. The Corelight sensor changes the raw traffic into rich metadata called bro logs or Zeek logs as of now, and is then sent to the Elastic Stack. We will be extracting, if needed, we extract files from the wire as well and send them to an extracted files folder or a system like an SFTP. Corelight with Elasticsearch helps augment incident response and threat hunting in the Elastic Stack. We have done a lot of groundwork around making sure that customers do not have to do all that manual labor. We have created dashboards out of the box around the common IOCs and threat vectors, around suspicious DNS queries, anomalies around SSL certificates, indicators of traffic being tunneled out, lateral movement indications, and beaconing and command and control. We also have community packages because Zeek has such a rich history and such a massive community around it. So community also helps us get new packages. Things like J3 and Hashware created by Salesforce give us visibility around encryption. We have done a lot of work with MITRE and the attack framework, and those packages are already pre-built. Awareness around IoT, and Google recently also had a parser around Gquick, which is also available within the Corelight appliances. So how do we help? How do we help analyze, or how do we help these incident responders and the SOC analysts to resolve these threats in a much faster way? We provide, like I said, we provide visibility from layer 3 to layer 7. And how does it look? So let's take an example. Let's take an example of one of the users getting an email, which is not a good email. Let's say it's the spear phishing email. The user gets the email, an SMTP log is generated because it is traveling through the network, and we pick up the traffic from the network. Once the email is opened, well, we see the connection log, which basically is the layer 3, layer 4 information around IP address, the port numbers, etc. If the user clicks on that link, which is present in that email, the browser will open up and an HTTP log is created. And these are all connected in a way with the universal identifier, and I will talk about that as well. Once the browser opens up, if a file gets downloaded at the backend, can be good or bad file, we will create a separate file log for that. If the malware is loaded, or if it contains a malware and the malware tries to reach out to the command and control server, a DNS log is also created. And this is how we kind of correlate all these different protocols using a single unique identifier. Normally, all this information or a threat hunt based on this would take a lot of time, because you would have to look at your email gateways, you will have to look at your forward proxies, your DNS servers, your firewalls. But Corelight makes it, or Zeek makes it easier for you to have a commonality across these multiple protocols, which makes it easier for someone to do threat hunt. And this is all presented on Elasticsearch. So what we can do is we can pivot easily through the threat hunt, and the workflow we will show in a demo as well. So you see, basic information like the source and destination IPs, which protocols are being used, which countries the traffic is coming from, how many bytes which are in that session. We look at things like the SSL certificates and so on and so forth. And we will be doing a proper threat hunt, and I will be going over the UI, the Corelight UI and the Elasticsearch UI to give you better understanding of how we do and how we correlate all of this. So why is Corelight your best next move? One, we provide comprehensive data. The deployment is extremely fast. It takes us 15 odd minutes to get that network traffic and send it to Elasticsearch. And because of pre-built dashboards, it makes it easier to visualize that very quickly. And it's one of the least disruptive technologies that you can use because it's out of band. So now I'll start the demo. Before demo, let me look at a few questions which are coming up, because there are a few of them, and then I'll start the demo itself.
Okay, Farhan, you want to start? You want to start with the question first, or you want to show the demo first?
I think some of the questions are around the people not getting the audio. So I will keep the questions at the end. We will probably save like 10 minutes in the end, and then we will take those questions one by one.
Yes, let's do that.
All right, so what you see right now on your screen is the Corelight UI. It's the latest and the greatest one we have, and it just got updated yesterday. And as you see here, this is our sensor. We don't have a dashboard, and the reason for that is we know Elastic has a phenomenal dashboard, very customizable with Kibana, and it can do n number of visualizations, whatever a person could think of, and all it needs is rich network data that we can provide. And once we provide rich data, we can easily visualize that data in Kibana dashboards. So all we have to do is tell the sensor, send the data and export the data to an Elastic stack, give it the prefixes, decide what logs to send. You can choose which logs to send. So if you already are doing something around DNS and you want to omit that out, you could. Normally, the beauty of Elastic Stack is that it is so extensible and flexible. You could probably send everything to it and keep it for a long time. We have packages built in. So, we have some core packages. If you want to have packages around encrypted insights, we have them as well. And they're as easy as just turning a radio button on and off. Doing this on open source Zeek would be a very labor intensive process, but Corelight just makes it easier to have all these new packages onboarded. So we have custom packages as well. So if you find a really nice custom package that you want to add, we could also add those. We have analyzers for files and Intel as well. So if you are familiar with Intel and input frameworks, we could also incorporate those in the log. So a log would be tagged based on the framework, and it would also give you better visibility. In case some customers are using commercial thread feeds like Anomaly, etc., we could also integrate with them and provide rich visibility on the traffic. This is the Elastic instance that I have set up. It has some data in it. I'm doing a search based on last 1 year. And what you see here is some traffic that's on the connection side. I see what services are running in my network. So I have a lot of HTTP, some DNS, some DHCP, SSL, and SSH traffic. Top queries around DNS. So these are my top queries. Top SSL servers, so all of them are here. Top protocols which are coming in, and countries which are trying to send me bad traffic. So, or general traffic as well. We could do both. So I see a lot of traffic coming from the US and a lot of traffic coming from Asia. Now, before I start, let's do a quick threat hunt, and then we would start going more in the details of how we can visualize this data in Elastic. But let's try and do something manual first before we go into the dashboards. So for example, a user calls a SOC team and says, I was watching a couple of websites, and then my laptop or my machine is not behaving properly. The information that the SOC has to go over is the domain name and probably the source IP address of the user. For the sake of the demo, this is the domain name that our user went to. We see that yes, there is traffic going through this domain. We could add the host IP, and we see, yeah, this is our source IP. I could add the path as well to see what kind of traffic is coming, and you see a couple of DNS requests. So that means he opened the browser as well, and the DNS requests are there. Now, if I go through the log itself, I can do a table form, or I can do a raw JSON. Both are available. I see within the DNS itself, and if people have used things like NetFlow or DNS logs, they would clearly see that the amount of information present here with Zeek data is extremely rich. So we have the common things like the answers, the hosts, and the query itself. We also tag every session that we have with a UID. It's a common, unique identifier across protocols. If I go down, I look at the HTTP. I'll say, okay, he opened the browser as well. I look at traffic. I see, okay, there is a GET request here, and the GET request basically says something was downloaded. I see a file name. It is a GIF file, so nothing to worry about so far. Corelight also analyzes the file. It checks the MIME type of the file, and the file is not a GIF file, it's an executable. So that clearly makes it easier for an incident responder to see, aha, this doesn't look good. Why would somebody claim to be a GIF and is actually a DOS executable? So what we could do now, and we could see how many of these files are out there. I could easily take the UID, which is a unique identifier, and Corelight also checks where did the file download from. what is a user agent. So we have all this rich information present, but I could just pick this up and just search based on last to see what comes up. And I see, okay, the connection log is there, HTTP, and I have some files as well that were downloaded. And I saw those files. This is the file that was downloaded. I could either do one of two things. I could take this file, send it to a sandbox, do an export, and let it check over there. But Corelight has already analyzed the file, and we know it's a portable executor. So it is an execution file. It's an exec. So what I can do now is I can just take the SHA, ask VirusTotal that, dear VirusTotal, can you check if anybody has flagged this SHA? And just to make it easier and quicker for the incident responder to take a decision. And lo and behold, there are 46 engines out there that say this is a bad SHA. So now I can start the process of the response that maybe I need to quarantine this host. Maybe I need to check for things like lateral movement. Maybe there is data exfil happening, and all of that can be done with Corelight data and visualized on Elasticsearch. So this is how easy it becomes when you have rich data to work with, to view. It becomes so much easier to do an incident response and a threat hunt. I could now go around my environment and say, how many times have people downloaded executable files? So things like that. I could do a search based on, I could do a MIME type. Yeah, I could do an easy MIME type search on a keyword called, let's do a star executable. Let's do it for MIME underscore type. Yeah, that's the one. Okay, this one. Let's change it to something higher, or let's do it here. Okay, for some reason I don't have it here, but it should come up. Anyways, I will go back to it later on. So this is how easy it becomes to search and scan and look at different aspects of a file and traffic based on protocols or based on traffic itself. I have a question. Ah, yeah, you're right. I'm missing the. Let's do it like this. RESP underscore MIME and types, and then do this, then do star and exec. And let's do an update. Yeah, so yeah, I was missing the S in the type. So you will see here, and I could add the MIME type. I could add this as a field, and I see all these DOS executables. Now I could also add the file name and check whether this is actually an executable file as it was claimed, or this is like a text file claiming to be an executable. And you could do this for any sort of traffic. And this is how easy it becomes to have this. I have created for one of the customers a simple report which says how many times did a file claim to be something that was different from the MIME type itself, and that is a good indicator of something that you should start looking at early on in your day when you're doing incident response. Looking at other stuff that we have built with Elastic with Corelight data or Bro data is we have done the common protocols. So things like connections, DNS, files, HTTP, what kind of software you're running, visibility into SSL and X509. So if you look at just the connections tab, we look at what are the top protocols, top inbound flows, and things like that. If you go down, we have connections per count. We can do it based on destinations, and this is all native visualizations within Elastic. You can change it, you can modify it. Elastic gives you the flexibility to decide and see what you want to see. You're not limited to a vendor held dashboard. It's extremely customizable. It's extremely rich. All you need is the right amount of data set, and you could create those visualization. I've done it based on country as well. And you could also do things like rare traffic. So if you see traffic coming from a country which you have not seen before, and you have all this rich data that you've stored for, let's say, a couple of years, you could also do things like rare traffic around, any parameter that you could think of, from a country to an IP to a hash to a J3. So because of the richness of Elastic and the amount of the data that is being fed into it, which is probably 1% of PCAP, you could have detections spanning a large data volume, and that gives you a better detection and a better alerting story. If I look at DNS, and all these are pre-built. So if I look at DNS itself, it looks at all my top DNS queries. What we have also done is, we get all the top queries of DNS, and you see, the main Googles and the Facebooks of the world. We also have things like, traffic to domains that do not exist. So if you see things like this, I have something called a pond.se, or some which is, half Unicode. So if you see traffic going to domains which are not registered or do not exist, that's a good indicator of command and control. And normally this should be blank. And the thing is, whenever I go into a proof of concept, or we talk to customers and we show that this is something that is happening, maybe over a tunnel protocol or otherwise, this is something that resonates really well with the SOC teams, that they have the ability to check very quickly that one of their users or one of their host machine is talking to something that is not a domain that is existing anywhere. We look at top originators by count. So there is this balance between a producer and the consumer of content. So if you are you're a web server, you are producing content and the host is consuming it, and that's how the dynamic of that relationship is. If we see it getting flipped, which means a user is producing content which is going out to the internet, we have a clear understanding that this has to be some sort of data expel. It could very well not be data expel. It could be somebody uploading a lot of information. But if that is not the case, and you have policies around that, and we see a lot of traffic coming from a certain IP or a certain host, which is sending a lot of traffic out, that's a good indicator of data expel, and we could start our investigation and our response based on that information. And all of this is given as a neat dashboard to our teams present in the SOC. We also look at files. So we can extract files from the wire directly at wire speed, and we can do all sort of files. So here you see I have some certificates, some plain text, and if you go down, I have some JSON as well. And I could take any file. It could be an Office document, it could be a PDF, it could be a Word, it could be a Flash file or an archive, and I could extract that and use it later on in a sandbox. So how many unique files we have seen? Again, this visualization is easily done on Elastic. What kind of files have we seen? What kind of packages? And you can always filter by value. And if you see a lot of DOS execs, you could always filter them and see how many users are actually downloading them. Maybe there is lateral movement around this. And if you go down, you see all the hosts, all the MIME types around those specific file names. In SSL, this was a very unique use case that we had. We look at all, because we are inspecting all traffic, we look at all the certificates as well. We also look at things like what kind of SSL version are they running on? Are they running TLS 1, 1.2, or what kind of ciphers are they running on? Are they running on the elliptical curve Diffie-Hellmans, or are they running RSA, or are they running an obsolete cipher like triple des, which Microsoft recently decided to not allow talk to their servers? So if you have an obsolete cipher and you want to have visibility that, can you tell me which of my servers are negotiating with clients on an obsolete cipher? This makes it very easy. Corelight makes it extremely easy. And normally, if you have a couple of websites, and all of these websites have certificates, and each certificate will have 8 to 10 ciphers or more, it becomes a pain to understand, which ciphers you would want to upgrade, or which are vulnerable or which are not supported. With Corelight, you could easily see that, yeah, there are a couple of ciphers which are obsolete, and there are clients still negotiating on them, and maybe this is where I should start getting them upgraded. And all of this is data that is fed by Corelight into the Elastic Stack. We also look at the validation status of the certificates themselves. So if a certificate has expired or is self-signed, or the name of the certificate is something that is weird, we could also flag that into Elastic, and you could also do reports around it and dashboards. So the summary as well. So if there are certificates that are expired, we would come to know, and you could also use this as a report and upgrade those certificates internally. Looking at X509 itself, we look at rare subjects. So if we find subjects which we have not seen before, we could also do rare. And the beauty about Elastic and Corelight is you could do rare on any parameter in that attribute list. And I will show you that attribute list in the end if we have the time. We could look at which SHAs are using, which is using elliptical curve. What is the average length of a certificate? If you have certificates with less than necessary key length, or it's not in tune with your policy, you could also look at that and highlight that and start upgrading those. And we could also look at the signing algorithms around those certificates. So this is basically a very high level information around the use of Corelight data into Elasticsearch, which gives you better visibility, better incident response capabilities because of the rich data that we have. We also have, because we are tapping the network and we are seeing all traffic, we also look at things like what kind of user agents they're running on. So things like Chrome, Firefox, Safari. We can also look into things like whether they're running a specific Python script or not, whether they're running on Apache. So all of this is coming from Corelight into the Elasticsearch. And all of this can be then used into a report. It can be used into a dashboard. And all of this has rich information present within the system itself. So this makes it very easy for you to understand what is happening in your network. I will stop briefly now just to look at, Samir, is there any critical question that we would like to answer based on the dashboard itself?
Yeah, we do have a few questions. One of them is, the question was, it seemed that the file hashes, like the person seen the file hashes, but he haven't seen any of the file names or the file paths. He said, does Corelight provide a way for you to get that?
So you want to know where okay, let's do this. So let's assume where is the file? Okay, let's take this one. This is where the file came from. So let's take the UID. Let's do it based on this. I will remove the filter. All right. And then let me add the file names. Okay, so I have the files here. So this is, let me just check, where is it? Okay, let me add the path as well. Okay, do I have the file name here? Let me do one thing, let me just make it easier for everyone. Yeah, so I have the file name here, as you can see. That's the name of the file that was downloaded. If I open the file up, that's the name of the file. And what was the second part of the question? I can now decide the path of where it was stored on the user machine. Is that the question?
Correct.
Yeah. So that would be on the host itself, right? So that means we have to have some sort of an EDR agent sitting on the host to identify and correlate that, okay, this file is downloaded, did it go to a 10 folder or some other folder? That would be
Yeah,
the EDR data that's also being fed to the Elasticsearch.
yeah. This means if they use Endgame, for example, to collect data, they can
Correct,
pivot from here to the endpoint data, and they will see the more information
correct.
about that file.
They could see a lot more. Maybe the malware tried to do elevation of privileges, or try to remove some admin access and so on and so forth. So with Endgame and that agent sitting on that host machine, they could do a lot more, not just understand where the file went when it was downloaded. So they have a rich visibility story around that as well. Maybe a process got created, maybe it latched onto an LAS ss.exe, or it did something else. So all that change in that system state would mean that, with Endgame on it, it makes it easier for them to not only see where the file went, but also go beyond that and see what the file actually has done on that system state.
Okay, great.
What's the next one?
Yeah, the other question is, say, they want a little bit more details about data collection for like the types that needed and supported.
Okay.
And also is the
So,
packet broker. Yeah, I mean, also they ask about question about the packet broker also. Yeah.
Okay. So since Corelight is an out of band solution, right? So we are not in line to traffic, which means we need some sort of capability to drive that traffic to our appliances. Now, traditionally, that capability would be something like a span or a tap port, right? Think about your Cisco's and the HPs and the other switches in the world. They could all do a span and a mirror. The challenge with that was it would sometimes drop traffic, or it would not give priority to the span traffic itself, and you couldn't do a lot of filtering on it. With the packet broker, think of companies like Gigamon, think of the companies like Ixia, Niagara Networks, Garland, and so on. There are many of them. What they have done is they've created these enterprise solutions to take copy from the network and give it to a solution, and Corelight being one of them. And you could do a lot of forking and filtering. And they are also able to do consolidation of traffic. So if you have a lot of isolations in the network, which would mean that it was difficult to correlate that traffic into one single stream, a packet broker would help in that as well. And we work with any packet broker. We are not tied to a vendor as such. Any vendor who can take a copy of traffic from the network and deliver it to Corelight is something that we can work with.
Okay, great. Also, we have a few questions about people that already using Zeek,
Okay.
and what will be the best way to send the data. I mean, I can answer this. I mean, we do have a bit module in 5-bit.
Yeah.
There's a module for 5-bits for Zeek. I mean, you can use that module to collect data from Zeek and send them to Elasticsearch. But I also recommend, and maybe can you tell us again about the difference between your solution and the open source Zeek?
Correct. So since we, Elastic and Corelight, they both come from rich open source heritage, there will always be some overlap within the technology. What Corelight has done is made that complex Zeek install a breeze with an SLA, with a appliance form factor, with a GUI as well. You don't have a GUI in the open source Zeek. It's all CLI based. You don't have integrations with the SIM as it would. There's a lot of manual work. There are packages on detections and packages on visibility that are specific for Corelight. And there is a lot of rich R&D happening on the Corelight side, which is a more commercial version, which would not be available on the open source platform. Having said that, there are companies who have the knowledge and the technical know-how to have those Zeek instances set up. And they are the first ones who come to Corelight and say, we have this massive Zeek infrastructure wherein we have a hardware from a vendor ABC, and we're trying to maintain this. But with Corelight, we can easily get this up and running in 15 minutes. The other major challenge with open source Zeek is the scalability. You can't scale beyond a couple of gig worth of traffic. So if you have, in our networks today, a couple of gig traffic is probably from one subnet. So you would have to have multiple of those Zeek installations. Whereas with Corelight, you have one appliance which can do 25 gigabits per second of throughput, and it's easier for customers to adopt that. Apart from that, you have all of the development team of Zeek, or majority of them are with Corelight. So you have that brains behind that product. And we are, we back our SLA as well. We have 24/7 support. You have access to technical account managers, access to early adoption packages, and all that comes with the commercial version.
Okay. I have another question. They're asking if can we incorporate a Corelight on the cloud platform like Azure with some other implementation?
Yes. So the short answer is yes. The long answer is Azure had something called the Azure Taps. They were doing a beta for them and this month or last month, but it kind of got shelved. We are ahead of that game in Azure itself. So I think Azure will start doing the GA January or February. Once that tap is commercially available. I think right now you have to be part of the beta program for the Azure Tap. If you have Azure Tap, or if you're part of that beta program, you can spin up a Corelight instance, and that will collect the information. On the Amazon side of things, we are there, and we've been there for a long time. But on the Azure specifically, you have to be part of the beta program for the taps.
I have a question asking, would it be possible to visualize performance on the network using the data that Corelight is collecting?
Yes, yes. Can we do it? Yes. So things like performance around there's a lot of this question comes up a lot because network teams always blame the applications and vice versa, and people want to know where the fault is. So we do have access to those information because we are managing. We have access to the logging, especially around faults, whether it's with the load balancer or the application itself. TCP windows, we also manage those. We also have visibility on them. So we have some use cases around network performance as well, though we are not an NPM as such, but there are use cases with Corelight data for network performance troubleshooting, so to speak. And I can share them with you. If you can note down this person's email or address, I could share with him some details around how we manage that. But this is very common. This question comes up a lot.
Perfect. Another question is it possible to send data to Kafka if the architecture there?
Absolutely. Absolutely it is. So one of the things that a lot of people are doing is that they're not sending data, and we've seen this a lot in the recent past, is they're not sending data directly to they're sending it to Kafka or Cloudera or Confluent or whatever version they want to use, and that becomes their data repository, and from there they send it to their SIM. Now with Elastic they can do it directly because Elastic has a big data warehouse, so directly send it to Elastic. But yes, we have customers who are sending it to Kafka. We do create multiple topics for each log, so that's something that you should know. But we have installations already in place where we are sending data to Kafka.
Perfect. And once the data is in the Kafka, we at Elastic we do have you can pull the data from Kafka using different solutions. We have Logstash that have a Kafka input. We also release a new file bits that have Kafka input. I mean, now you have two possibilities to use, like two solutions to pull data from Kafka to Elasticsearch. Let's see. I have some few questions, maybe that's more related to Elastic. We have question by, for example, about do we have out-of-the-box rules? In the latest version, we are providing out-of-the-box machine learning jobs for security that not only look at the threat, like known threat, it helps you to find anomalies. It helps you to create the baseline for all the different entities you have, like baseline for your network, baseline for your servers, etc., and identify any anomalies. And that helps to identify known and unknown threats. In future version, we also we will include more and more machine learning jobs and also alerts, rules detections in future release. I think I will continue answering some questions, but for the webinar is already we're going to finish. And thank you all for your time, and I will continue, like I said, replying to a few questions. Thank you. Bye.
Thank you so much, guys.